Okay, so in the lesson that we're about to go over, we're going to go into graphing quadratics. For the graphing quadratics, we're going to go over the vocabulary, um, input-output tables, and using the line of symmetry for this lesson. Um, this is going to cover the whole week, so feel free to break this up into smaller pieces. I'll try to put some bookmarks on the bottom so that you can skip through to the parts that you need for the different worksheets that I'm going to give. So let's get to it. So first off, to graph quadratics, we have to kind of recall what a quadratic actually is. So in the previous chapter, we saw a lot of expressions that look like this. And if you take a look at these, if you can remember what makes all of these quadratics, so take a little bit and look at it, you should have come up with the degree. So the highest degree, which is the exponents on each of these, the highest exponent for the variable term, is degree 2. So degree 2s are quadratics. So while last chapter we went up to like higher degrees, like degree 4s, 5s, quintics, quartics, things like that, this chapter is all about the quadratics. Now, since we're going to start graphing this, it makes sense to kind of go back and think about a previous thing that we've graphed, which were linear equations. So if you remember, linear equations had y equals mx plus b form, so y equals 2x plus 1. When we first learned about linear equations, we worked with an input-output table, or an xy table. So basically what we did was we plugged in x values, and we just kind of chose some. These are some at random. I like to start at the origin 0, and go up a couple and go down a couple when you're first starting out. But basically, you plug a 2 into here. 2 times 2 is 4, plus 1 is a 5. Plug a 1 into here. 2 times 1 is 2, plus 1 is 3. 2 times 0 plus 1. 2 times negative 1 plus 1. And then 2 times negative 2 is negative 4, plus 1 is a negative 3. So that's nothing new. We just kind of took the x values and plugged them into the linear equation. And then the next thing we did was we started plotting them on a graph. So 2, 5, you go right 2 and up 5. 1, 3, right 1, up 3. 0, 1, stay still, then go up 1. Negative 1, negative 1, left 1, down 1, and then negative 2, negative 3. So that's how we started graphing linear equations before we did the y equals mx plus b form, and then figured out there's a little bit of a shortcut there. We're going to find out shortcuts with the quadratics too, but for today we're going to be kind of focusing in on just seeing the pattern, because when we graph these, we see a pattern emerging. That's a lot about what mathematics is trying to look at things in different ways and seeing if we see a pattern. So the pattern that we saw here was that for all the x values we were plugging in, we kept seeing they were actually lined up. So we drew a line, and that was the shape of the graph of a linear equation. Now, quadratics, let's kind of take a look at this now. So quadratics starting off with just x squared. Now, if you notice, we can't just graph x squared on a coordinate plane like this because we need an x value and a y value. So just like this had a y equals, we are now going to throw a y equals onto there so we can make a coordinate plane. But before we do that, let's go ahead and make an xy table. And I'm going to pick the same values, just starting at 0 and going up a couple and down a couple. I will eventually show you how to pick these values, but for now, I'm going to give you these values so that you can kind of work with them and just plug them in. So what I like to do is anywhere I see an X, I'm going to put a blank spot. So I'm going to put a pair of parentheses because I know I'm going to fill in this 2 there. Now, before I start filling in each one, I call this my frame. Once I get my frame down, I'm going to put it down on all of these. That way I just know that I have my blank spot and squared. Now what I'm going to do is anywhere I see a blank spot, I know that used to be my X, so I'm just going to plug that in. And I'm just going to square all those values. So again, take your X value, plug it into where the X was, and then you got your substitution step done. So 2 squared is 4, 1 squared is 1, 0 squared is 0, negative 1 squared is 1, negative 2 squared is positive 4, because it's negative 2 times negative 2. Keep in mind, if you feel like I'm going kind of fast through this video, feel free to stop, rewind, all that good stuff so that you can kind of catch up. But I do suggest that you kind of watch the video before you take too many notes. That way you kind of get the feel for how this is being done. All right, so just like we did with linear, The next step would be to graph these things. So I plugged in an x value, I got out my y value. So my first point is 2, 4. Next point, plugged in a 1, got out a 1, so 1, 1. And then I plugged in a 0, I got out a 0, so 0, 0. Plugged in a negative 1, got out a positive 1. And then I plugged in a negative 2, and I got out a 4. And I got this sequence of dots, points. So what I'm going to do now is I'm going to clear off all this stuff, and we're going to just kind of analyze these points. Now, looking at these points, with a linear, they were just in a straight line, so I just drew a line. Now, obviously a line's not going to work. I can try to connect these all I want with a single line. I'm not going to be able to get all those red points on a single line. So that's basically what we're trying to do here, is figuring out what shape can we use to connect all these dots. So we used linears in the past. This is not linear, so that's not going to work. We also did absolute value. This kind of looks like a V, so that was an absolute value graph. But if I notice, or if you notice, the V is not quite going to do the job either, because I'm always going to be missing a couple of those points. Even if I tilt it to the side, can't seem to get it. So let's take a look at the table again. Looking at this table, whenever I plug it in a 2, I got a 4, 1, 1, 0, 1, negative 1, 1, negative 2, 4. Now, let's say I plugged in a 3. Just taking another number up because it went to 2. Now I'm going to 3. Plugging in 3, I get a 9. So if I went one number up, it's going to go one number down. Plugging in negative 3, I get a 9 as well. So there's a little bit of symmetry going on here. I got a 9 here, got a 9 here. So when I go further out to negative 3 and positive 3, I'm getting points that are even higher. So I got to think about a shape that I can hit all these things with. Now, it's not going to have a straight line. I have to curve this a little. So your graph is going to look something like this. This is called a parabola, all right? So the next thing we're going to go over is just basically going over some vocabulary. That way, when we're talking about this parabola, we can kind of have a solid foothold on what we're talking about. So 3 new terms that we're going over that we have not covered with other types of things before was, or is, the vertex, maximum, minimum, and then the line of symmetry. So let's take a look at the vertex. So the vertex is basically going to be this middle point right here, okay? It's not really a middle since it goes on forever, but a lot of people like calling it a middle point, so I'll just call it a middle point just so you can kind of see it. So let's see if you can spot the vertex for each one of these parabolas. So I'm going to take a minute, see if you can figure that out. I'm about to show the answer. And if you picked all of those green dots, you are correct. So every single one of those green dots are your vertex, is the vertex for each one of those parabolas, okay? It's right in the middle, right in the middle, 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 middle. All right, so that's a vertex. When I'm talking about maximum and minimum, it kind of depends on what your graph looks like. And this is actually really closely related to the vertex. So maximum minimums are basically depending on how your parabola is orientated. So if you see this one's upside down, your vertex is at the very top. So this one is at the top. This one looks like it's at the bottom. This one, as I'm coming up, that's at top, bottom, bottom, top. So these 3 right here are considered to have maximums. So if you kind of look at these, you can see that that's because the vertex was the very peak of every single one of these parabolas. So that would mean that for a minimum to happen, it has to be at the very bottom of the parabola. So that's it for maximum and minimum. So if I'm talking about a maximum, I'm talking about the top about a minimum must be at the very bottom. All right. And line of symmetry. So line of symmetry, you have to know what symmetry means. Symmetry means that it looks the same on both sides. It's a kind of rough description of that. So if we take a look at these points again, and if I were to draw a line down the middle of these points, what do you notice about the green dots and the blue dots that I have up here? If you're seeing that they're the same distance or about the same distance, or they should be the same distance from this line, that means it has symmetry. So that's why this is called the line of symmetry, because it basically cuts the points into equal pieces. So they're the same distance from this line. So those green points are the same distance, and then those other points are the same distance. So if I take a look at these graphs again, um, and if I were to draw a line of symmetry down each one of these, and it has to be a vertical line when we're dealing with these type of parabolas. We're not going to have them go to the side in this class, at least. So see if you, like on this first one, it would be right here. So see if you can imagine where this line of symmetry would be for each one of these. So this next one would be about right there. That one should be right there. This one would be right there. And that one would be right there. And this one would be right there. Now, if you notice on all of these, basically the line of symmetry is going through the vertex each and every single time. And that's not a coincidence. That will always happen. So your line of symmetry has to go through your vertex in order to work. All right, so a couple of problems on your homework are going to look like this. I'm going to go ahead and give you a quadratic. This is a quadratic equation. I'm going to give you the parabola already drawn. All right, and then I'm just going to ask you to identify these pieces. Now, there's a few more pieces because these were just the new pieces. We have some pieces that we covered before. X-intercepts, hopefully you're familiar with those. That's where it crosses the x-axis. This is where it crosses the y-axis, domain, and range. All right, so let's go over each one of these because, like I said, your homework will look a lot like this. So your vertex, again, that is the middle. So that's that red dot right there. And it's a point. So you need to make sure you tell me what point that vertex is. So that point is at -2, -1. So that's it. Just look at the vertex, make sure you know which point it is. Next one, max or min. So you have to tell me, is that vertex the maximum or minimum of this graph? And if you look at it, it's at the bottom of the graph. That means it is a minimum. And if you want to get technical with it, it's a minimum value. You use a y value for it. So the minimum value is -1 because that's the lowest it goes is -1 on the y-axis. Next up, line of symmetry. So I want you to draw this in. It's going to be a dashed line because the line of symmetry is actually not part of your graph. It just helps you kind of see where the graph is symmetrical. So that's why it's dashed. It's not an actual solid line. Your actual parabola is just going to look like this solid blue line, but the line of symmetry is going to help you out a lot later on. It's going to save you a lot of work. So it's a very important part. But the line of symmetry is a vertical line, which means it's x equals. An x equals line is a vertical line, and it's at -2 on the x-axis. So x equals -2 is your line of symmetry. All of our lines of symmetry for our parabolas that we're working with in this class are going to be x equals. You're not going to have a y equals, it's just x equals. All right, x-intercepts, just figure out where your graph touches the x-axis. Right here at these green points right here, that's where our graph touches. So that looks like it's at -1 and -3. So your x-intercepts are -1 and -3. Your y-intercept is where your where your graph touches the y-axis, which is right up here. That looks like it's at 3. And then domain. We covered this briefly in first semester, but basically domain is how far side to side your graph goes. This graph keeps going side to side, and all of our parabolas will. So just automatic here, domain is always going to be all real numbers for this graph. You're not going to have any types of restrictions on that. Okay. Your range, though, is how high and low your graph goes. Now, just the fact that you have a minimum tells you it's not going to keep going down. So your range, if you look at your graph, it's all above this point right here. So that's at -1 on the y. So your range is always your y values. So basically this graph is going to be y is greater than or equal to -1 because it's all above -1. Okay, so domain should be pretty easy. It's always all real numbers. Range is the one that could get tricky. Just make sure you look at where your highest or lowest point is and figure out where your graph exists. Does it exist above that point or below that point? It's below it if it turns upside down. All right, so that's going to be what your problems are going to look like for your homework. Just to kind of show you this too, if you remember last chapter, we had quadratics, and then we factored them, and they looked like this after we factored them. So this is still a quadratic. It's just that it's in factored form. But this is the actual graph of it, and you're going to have the same kind of problems, though, once I give you the graph, so you actually don't do any work for this graph. You just got to figure out all these pieces. So the vertex, it's the bottom, so it's negative. It's 2, -9. Looks like it's a minimum again. Line of symmetry is that line going right there, and that looks like that line goes through a 2. X-intercepts right there. See if you can figure out the y-intercept. Should be right there. Domain, that's outside to side. That's always going to be all real numbers. And then your range, again, this is the lowest point, so everything is above there, so y is greater than or equal to -9. This sign will flip to less than if it's upside down, but this is not upside down, so don't worry about it at this point. Okay, so that's it for identifying the parts. That's going to be the first worksheet. I'm going to go ahead and move on to working with the tables. So this is going to be the second worksheet that I'm going to give you to practice with. So working with tables, basically we're just going to take some quadratic equations and practice plugging in x values and getting out y values, because we're going to be doing that a lot in this chapter. So first off, you want to start with a table, and I want to have, I want to start off, or actually I'm going to give you all of these x values because I still haven't shown you how to figure out where to start this. Since x can be all real numbers, you can start wherever you want, but I want this done in a certain way because hopefully you could tell the vertex is pretty important. But the only way for you to figure out where the vertex is in a future chapter. So I'm going to go ahead and just give you the x values to plug in. Okay, so on your homework, this part will be filled in. Usually I start in the middle, I go a couple up and a couple down. So again, wherever you see x values, you are going to put in blank spots and just do that all the way down. So you had x squared minus 2x, so something squared minus 2 times something, just leave them blank. So next step, you're going to substitute. So just throw those x's in there, and those are still x's, so just go ahead and put them in the other side too, right? And at this point, it's just order of operation stuff. So for this first one, you're going to square that. So 3 squared is 9. Don't subtract yet. Next, you're going to multiply. Since this subtraction kind of separates these two, I'm going to go ahead and do those two at the same time. So 3 squared is 9 minus, and then 2 times 3 is 6. 9 minus 6 is a 3. Okay. 2 squared is a 4. Minus 4 is 0. 1 squared is 1. 2 times negative 2 times 1 is a negative 2. So 1 minus 1 minus 2 is negative 1. 0 squared is 0. 2 times 0 is 0. So 0 minus 0. And then negative 1 squared is 1. Negative 2 times negative 1 is a positive 2. So you should get 1 plus 2 and get a 3. Now, here's a little bit of a hint. If you're doing this correctly, because I already chose the x values for you, if you notice the answers that you're getting, the middle one is right here, but then after the middle, the one that goes up and down, hopefully you notice those are the same. So you got a 3 and a 3 here, you got a 0 here, a 0 here. So if you see that pattern going on, you know you did it right. If that pattern's not happening, that means something went wrong, especially since I'm the one that chose your x values. Okay, so I'm choosing your x values for you so that you can try to pick up on this pattern. All right, so next up we would be plotting these points. Now on the homework, I'm not asking you to plot them, but I'm going to show you right here so that you can see what it would look like. So if I were to give you a graph and you're going to plot them and graph them, it would look like this. All right, so you would plot all 5 of these points and then just draw that parabola through them. All right, let's go and try another one. All right, and you might see something like this. Again, this is a factored form. This is still a quadratic, but it got factored. So if you were to multiply this back together, you would get one that looks like the previous problem that we just did. Yeah, to go ahead and make a table again. I'll pick your x values for you. I found the vertex is at -3, and then I go a couple up and a couple down. All right, and again, you don't know how to do this yet, or maybe you can figure it out, but for now, I'm just going to give you these. All right, so with this one though, I don't need to put an extra set of parentheses around these x's because nothing's being squared or anything. It's just your x value plus a 1, then you're going to multiply that by your x value plus 5. So I'm going to go ahead and just leave some blank spots. So blank plus 1 times blank plus 5. And I'm going to write that all the way down. Okay. Now what I'm going to do is wherever I saw those x's or I left those blank spots, I'm going to go ahead and put in my x values, and it should look like this, okay? So again, put in your blank spots and then fill in your frames with your x values. Okay, again, order of operations, you're going to do the parentheses first. Negative 1 plus 1 is 0. Negative 1 plus 5 is 4. So 0 times 4. And then what is 0 times 4? Should be 0. Okay. Negative 2 plus 1, which is negative 1. Negative 2 plus 5, which is a 3. And that'll be a negative 3. Negative 3 plus 1, and times negative 3 plus 5. Should be getting that. And at any time in this video, if you want to see if you can do this on your own, feel free to kind of see what I'm doing, and then you can even pause and then go back and try it and see if you can get it, okay? So you should get that. And negative 5 plus 1 is a negative 4. Negative 5 plus 5 is a 0. And again, you can double check your work. This middle one is a negative 4. As you go up and down, those should match. If they are not matching on your homework, something's going wrong, okay? And then those are your points. Input output table gets us points. And we are not graphing for the homework yet, but this is what your graph would look like, okay? All right, and then that's going to be the second worksheet will be around that concept of just practicing with the tables. So I know this video is running kind of long. We got one more topic, but keep in mind this is for the whole week. So you got these 3 different things. I'm just making it all one video. Feel free to kind of jump around to the different parts of the video to figure out which parts that you need to look at before you do the work, okay? So the last worksheet is going to be about using the line of symmetry that we learned about towards the beginning. Now, I had told you that the line of symmetry actually saves you a lot of work. So here's how this saves you work. If you look at this table, we did a whole bunch of work to get 5 points, right? 1, 2, 3, 4, 5 points. Now, what the line of symmetry does, it gives you kind of like free points. As long as you have 1 point, you can actually get another point by not even doing very much work. So if I give you this information, so you know the vertex of the parabola is at 4, negative 3. And then you also know that there's 2 other points at 3, negative 2 and 2, 1. So we're going to use this information to find 2 other points to make our parabola. So I'm going to start with a graph. Let's go ahead and plot these points. So I know the vertex is at 4, negative 3. So I'm going to put a point at 4, negative 3. Now that tells me a lot. Since I know that's the vertex, I know that that's going to be the middle of my graph. I know it's either going to be a maximum or minimum. I also know that there's a line of symmetry that goes through that. So I'm going to use a line of symmetry right now because I know that's going to split whatever parabola that I have here. I don't see one yet, but there's going to be one here. It's going to split it in half. So let's plot those other 2 points now. Once you have your axis, your line of symmetry. So you got 3, negative 2 and 2, 1. Okay, so 3, negative 2 is the green one, 2, 1 is the purple one. Hence the outline, okay? So this is starting to look kind of familiar to what we just saw in the previous problems. We are missing some points because I told you you need 5 points. So you got 1, 2, 3. You can actually draw a graph with less than those or more than those. I just want to see 5 points in my class just to make sure that you know kind of a better idea. Well, basically, the more points you have, the better your parabola looks. So I think 5 is a kind of happy medium there. So if I look at this green dot, I can see that it's about 1 unit away from our line of symmetry because it's at 3 and this is at 4, and I can just count this 1 box over. So I know that I must have another dot over here because I know that this splits it in half. That's how you use it. I didn't have to do a table. I didn't have to do anything. I just know that this is my line of symmetry because it goes through my vertex. So if I have a point here, I must have a point over here. It's kind of like a mirror, I guess. Well, not really like a mirror, but you just know that they're about this. They are the same distance away. Okay, so this purple point, if I look at this, it's 2 units away from here. So I just got to draw another point 2 units away on the other side. And if you look at this, this now looks like the parabolas that we were drawing. And now I have 5 points for my parabola. So even though I only had 3, since I knew where my vertex was, I could go ahead and get my other 2. Okay, so that's what the line of symmetry does. Instead of making that whole big table, you could actually do this. Okay. Another way this might look on your homework, use the information below to find two reflection points. Oh, I forgot to tell you what those were called. So the things that we just found, um, because these points were given to you, we reflect these. This is called a reflection. We reflect these over the line of symmetry. Okay, so that's called a reflection point. So this is a reflection point. That's 5, -2. I wasn't told that. I found that by reflecting over this line. Same thing here. This point over here is a reflection point. Okay, so when I say reflection point, that's what I'm talking about. Those points that you weren't given, but you can find by using the line of symmetry. Okay, so let's go back to that problem. All right. So this one, same thing we were doing before. We're going to graph this just to kind of help us kind of see. Now, there are other ways to do this. Graphs are a very visual way of doing it, and we're getting into graphing, which is why I'm using this right now. But we're missing something. I right now don't know which one of these is my vertex. Okay, just because this one's in the middle doesn't necessarily mean it's the vertex on my table. I mean, it's going to be, but it's not necessarily like that. So I'm going to tell you which one the vertex is on your homework, okay? So right now, this is your vertex, all right? So go ahead and plot that first. Once you know your vertex, plot it and draw your line of symmetry because that's going to make your lives a lot easier. Let's go ahead and plot those two other points. So we got 6, 5, and 1, 0. There's 1, 0. There's 6, 5 over here. All right, it looks like we have points on both sides, but just focus on one at a time. So if I look at this green one, that's 2 away. So I'm going to go 2 the other way. All right, this purple one is 3 away. So must have another one that's 3 over on this side. And there you go. You got your 5 points. Draw your parabola, and you are done. So it's about a 30-minute video, so about 10 minutes each section. But again, this video is long because it covers all 3 topics we are going over for this entire week. Feel free to jump around on the bookmarks page and make sure that you stop by or email me if you have any questions or need any help. Okay? Okay, bye-bye.